Hello, this is question 5 on your P3 January 2023 from Edexcel from the international paper. So you have to prove this trigonometric identity. And when you have to prove a trigonometric identity, you can start from the left hand side, work your way out to this side, or the other way around. And sometimes it doesn't work in the first attempt, so it's just trying something different. I'm going to start with this side because as I have trigonometric ratios from 2x, I will be able to use the formula for the double angle, so I think it makes more sense. So I have 4 cot 2x cosec 2x. I know that cot is the reciprocal of the tan, so it's going to be cos divided by sine. And I know that cosec is the reciprocal of the sine, so I'm going to write 1 over sine 2x. Yeah, so this is going to be 4 cos 2x divided by sine squared 2x. Sine squared 2x. And now I'm going to use the double angle formula. So I know that cos 2x is cos square x minus sine square x. And sine 2x is 2 sine cos, but it's squared. So I go to do 2 squared, 4, and then sine squared cos squared. I cancel the 4's and I'm going to divide. So I'm going to divide this by the denominator, then minus this by the denominator, because I will be able to cancel some things. So when I divide this by the denominator, I will cancel the cos square and I have 1 over sine square. So 1 over sine square. And it starts to look okay because I have x instead of 2x and some squares like I have here. So I think we are doing it the right way. Then minus, when I divide this by the denominator, sine square is gone and I have the reciprocal of the cos. So 1 minus cos square. And now I have to try to get this from here to here. So I know sine is the reciprocal of the cosec. So this is cosec squared minus, and the reciprocal of cos is the sec. So I have sec squared. And I have tan and cot. And I have, remember, an identity that relates them both. So I know that 1 plus tan squared is sec squared. And I know that 1 plus cot square is cosec square. So I'm going to use this to write sec and cosec in terms of tan and cot. So the first one, cosec square, is 1 plus cot square. And then minus, instead of sec square, I'm going to write this. So minus 1 plus tan square. And this is going to be the 1 with the 1 are gone, cot square minus tan square. That's precisely what I needed to prove. So cot square x minus tan square. And as this is an identity, I could write all this, so all the way. Yeah. This is what I had to prove. So we have finished with that. And now they say hence solve this equation. This expression on the left hand side is precisely what I have here. When they say hence, that means that it's going to be easier to use this and substitute this expression by this. So I'm going to write the equation using my, so this is B, this was A, the identity that I use. So cot square x minus tan square x. Yeah, so all this bit is cot minus tan square is 2 tan squared. Is 2 tan squared. And now this equation is, they are using theta. So I'm going to change that by theta. So this is theta, 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 just to do it properly. So I have cot squared theta is 3 tan squared theta, which means that remember that cot is the reciprocal of tan, so this is 1 over tan squared. When I multiply both sides by tan squared, I have 1 is 3 tan to the power of 4 theta, which means that tan to the power of 4 theta is 1/3. So tan theta is 4th root of 1/3. I do that with the calculator, and I get that theta, they say to two decimal places, is in radians. Be careful because the interval is in radians. So you put the calculator in radians, you do tan minus 1 of this value here, and you get 0.65. But this could be negative as well, which means the value here could be negative as well. Yeah, so plus, minus, we have two values for theta. Yeah, and that's all with this exam question.